Assalamualaikum and good day. So in this video we're going to discuss let me say the last subtopic for chapter 3, so which is known as solving the simultaneous differential equation. So I know that we still have 3.9, which is going to be the application problem, but for the application problem we're just going to sort of revise all the methods that we have seen before. So therefore this is going to be the last new thing that you're going to come across in chapter 3, which is solving simultaneous differential equation. Alright, so the thing is that in the previous two chapters, chapter 1 and chapter 2, so we haven't yet solved simultaneous differential equation, just differential equation, but not simultaneous. Simultaneous means that you have two equations and you have to find two solutions that fit both of the equations. It's going to be true for both of them, right? So that is simultaneous equation. Alright, and so far, from the methods that we're going to discuss, Laplace transform is the only powerful method that is able to solve for simultaneous differential equation. The methods that we have seen before, no, it couldn't do such a thing. Only Laplace transform can. Alright, so here, now that I'm going to deliver the idea of simultaneous differential equation, I don't want to scare you guys. So I'm going to start with a simple equation first. I'm going to start with this two equation. So my first equation is it's going to be x plus y equals 0 and 2x plus 3y equals 4. So these two, they are not differential equation. They are just simple equations that you have seen before. This is just basic simultaneous differential equation, because I'm going to give you the idea. So because the methods that we're going to discuss as they solve simultaneous differential equation will be actually the same idea as how do we solve for simultaneous equation. Remember, when we solve for simultaneous equation, there are two ways that we learn how to do so. So the first method is called substitution and the other one is called elimination. Probably you know how to do it, you just don't know the name. But this is what we learn in high school. So how do we solve for simultaneous equation? It will be either one of these two. Let me start with the first one, substitution. Okay, substitution means we're going to substitute one equation into another. Now we have two equations. So usually what we'll do is that we're going to modify the simpler equation and substitute that into a complicated one. So let me put over here simpler equation into the complicated. For example, for this case, I'm going to take simple equation as being the equation number 1. And from equation number 1, I can write that x is going to equal negative of y. And what I'm supposed to do with that is that I'm going to substitute this new equation, not new, but this newly arranged equation. So I'm going to substitute into the more complicated one, which is going to be equation number 2. So whenever I come across x in the equation, so that will be replaced by negative of y. So here my equation is given by 2x. So 2x plus 3y equal 4. So now I'm going to substitute the x part right here. So I'll end up with a 2. So x is now going to be replaced by negative y. So plus 3y, and that is going to equal 4. So this is the reason why we use elimination, substitution. So what happened is that now our equation is only in terms of y. There is no longer x in here. X is no longer in there. So that was what we wanted. When we substitute, we get rid of the variable and only left with 1, so that we can find the first solution. And for this case, what happened is that when I simplify this, I'll have 3 minus 2, so that is going to equal y. So my y value is going to equal 4. So this is basically my first solution. Because when we solve for the simultaneous equation, you have to find the solution for both of the variable. And for this case, you have to find what is going to be the value of x and what is going to be the value of y that satisfy both of the equation. So that is why we're not done yet. Now that we already have y, we need to figure out what is going to be x. And how do we find x? It's going to be easy. All we have to do is use back the original equation given. And I can simply use the equation over here. So the fact that x is going to equal negative of y. So therefore, my x value is going to equal negative of 4. So that is why this is going to be my second solution. So x is equal negative of 4. It doesn't matter which one you find first. You can either find x first and you can also find y first. That will be the same idea for the case of simultaneous differential equation as well. Alright. And if you don't want to use elimination, so that is going to be another method, which is called as being elimination. So actually, if you ask me, I'm not really comfortable with the idea of substitution. When it comes to simultaneous differential equation, I always use elimination. I'm used to that, but it's up to you. I'm giving you options over here, so feel free to choose. Okay, so elimination is that you have to think about like which variable to eliminate. So for example here, so which variable to eliminate. So for example here, so let's say I'm going to pick x to eliminate. So here what happened is that for the first equation, my coefficient of x is given by a value of 1. And for the second equation, the coefficient is given by the value of 2. In order to use elimination, so let me put a remark, the coefficient of the variable must be equal. The variable must be equal. So that is why, how do I make them equal? So I'm going to multiply the whole equation 1 by 2. So when I multiply, I'll end up with 2x plus 2y equals 0. Remember, when you multiply the whole equation, left and right. And then I just copy down the second equation, which is 2x plus 3y equal 4. And at this stage, when you want it to eliminate the variable, you can either use subtraction or addition according to the situation itself. And for this case, when I want it to eliminate x, I'm going to use the minus operation, subtraction, because I know that 2x minus 2x, so that is going to be 0. So that is why it is called elimination, because we eliminate one of the variable. So now let's simplify this. So I have 2 minus 3y is going to be negative y is going to equal negative of 4, 0 minus 4. So my y value, that is going to equal 4. So that is going to be our first solution. And of course, that will be the same idea as previously. How do we find the second solution? So use back the original equation. So I know that from 1x plus y equals 0. So I know that x is going to equal negative of y. So x is going to equal negative of 4. So that will be the solution. So either you use elimination or either you use substitution, the answer will be exactly the same. Right, so which one are you comfortable with? It's totally up to you. Right, but let me say that again. When you substitution, you substitute the simpler one into the more complicated one. So that is the key point. For the case of elimination, what you have to do is you have to make the coefficient of the variable equal. Then only like you start doing the operation to eliminate one of the variable. Okay, so now that you have the idea, so what I'm going to do is I'm going to show you 2 examples. For the first example, I'm going to use the substitution method. For the second example, I'm going to use elimination. And for you, I want you to pick which one that you are more comfortable with. But what I notice is that it's going to be something like this. If it's first order differential equation, it's going to be pretty simple equation. So equation is not too long. There will be the terms will not really be that fancy. And substitution or elimination both are possible. But as you go to second order differential equation, for example, like the equation over here, so this is no longer first order, but it's going to be second order. Okay, automatically it's going to be more complicated. I noticed that it is higher chance for you to get it right by using elimination compared to by using substitution. But again, I don't want to restrict your choices, so that is totally up to you which one that you're more comfortable with. So I've given you the idea. Okay, so now let's start with this particular example. So I'm going to start with my first example. I have 2 first order differential equations, dx over dt equal 3x plus 4y. And then I have dy over dt is equal negative x minus y. So that is going to be my second equation. So step number 1. Okay, and don't forget about the initial conditions. So we have 2 initial conditions. So the first one is x0 is going to equal 1 and y0 is going to equal 0. So the first step that we're going to do is when we want to solve simultaneous differential equation, so we're going to Laplace both of the equations. So let's start with equation number 1. So this is equation 1. I'm going to Laplace both sides of the equation. So I'm going to have Laplace of x prime. Now I'm going to apply the linearity theorem right away. Laplace of x prime is going to equal 3 Laplace of x and plus 4 Laplace of y. Remember I told you before the fact that this variable is not just x by itself, it's actually x of t, and this is actually y of t. Right, so now we're going to Laplace the derivative first order derivative x prime, and according to the formula you can refer to the appendix of the final exam. So the fact that when we Laplace x prime, so that is going to equal s capital X of s minus x of 0, and please bear in mind, let me be able to differentiate between your capital and your lowercase. Right, so that is going to be on the left hand side because we only have one term to differentiate, and on the right hand side I'm going to have a 3. Laplace x is going to be capital X of s, and plus 4 Laplace y is going to be capital Y of s. And if you notice, this is going to be a very similar idea to solving differential equation, the previous topic 3.7. After you have Laplace each of the term, you'll substitute the initial condition. So this is where my initial condition position x naught, and from the question, the x naught value is going to equal 1. And whatever terms that are the same, that share the same variable, so this is xs and this is xs as well. So what you want to do is you are going to put them together. You're going to factorize them. So therefore I'm going to have xs. This is going to be s minus 3 minus 1 from the initial condition. And that is going to equal 4 capital Y of s. And this is going to be my equation number 1 after I am done Laplacing it. So I'm going to call this as my equation number 3. So now we're done with the first equation. We're going to do the same thing to the second equation as well. So equation number 2. So I'm going to Laplace both sides of the equation as well. So let me put that in blue. So I'm going to find what is the Laplace of y prime, and that is equivalent to a negative Laplace of x minus the Laplace of y. I simply apply the linearity theorem. And according to the theorem, again, when I Laplace y prime, I'll end up with s capital Y of s minus y of 0. And on this side is going to be negative capital X of s minus capital Y of s. So we substitute initial conditions, y naught, according to the question, y naught the value is going to equal 0. And terms that are the same, collect and put them together, ys and ys, so put these two together and factorize. So I'll end up with ys multiplied by s plus 1, because I have to move this to the other side of the equation, and that is going to equal negative capital X of s. Or I can write that, so xs is going to equal negative y of s multiplied by s plus 1. And I'm going to call this as the fourth equation. Right, so after I Laplace equation 1, I got the third equation. When I Laplace equation 2, I get the fourth equation. Alright, so now after you are done with step number 1, you Laplace both equation. Okay, step number 2, you use substitute or elimination. And I've mentioned this to you before. For this particular example, I'm going to use substitution. Elimination. Okay, I'm going to use elimination, and I'm going to get rid of one of the variable. Okay, remember the rule for when we use substitution is that we're going to substitute a simpler equation into a more complicated one. And no matter how you look at this, so number 4 is definitely going to be the simpler one, and this is definitely going to be a little bit more complicated. So that is why I'm going to substitute 4 into 3. So let me put over here. So what I'll do is I'll substitute 4 into 3. So let me copy equation number 3 first. So equation number 3 is given by xs multiplied by s minus 3 minus 1, and that is going to equal 4 capital Y of s. And I'm going to substitute with this equation right there, for which I'll be substituting the x of s. And according to the theorem, so x of s is going to, not the theorem, according to the equation that we have, so x of s from equation number 4 is going to be negative y of s multiplied by s plus 1. So this is going to be my x of s. Okay, and the rest of them just copy it down. So I'm going to have multiplied by s minus 3 minus 1. That is going to equal 4 capital Y of s. So notice what happened is that after we use substitution, so now everything in terms of x is gone. See, x is gone. So this is what we wanted. We want to get rid of one of the variable. And now that I've got rid of that, I am able to find what is going to be Y of s. So that is going to be the third step that you have to do. I'm going to find one of the variable. So for this case, it's going to be ys. Okay, so now how do I find ys? First of all, I'm going to have to rearrange this a little bit. Let me write this, let me change in terms of positive and negative of this function. So I can write that y of s. So if I were to multiply both of this and expand the bracket, I'll end up with s squared. So that will be minus 2s minus 3 plus 1. And that is going to equal negative 4 capital Y of s. And if you notice here, so these two, both of them are in terms of y. This is ys and this ys as well. So that is why I'm going to put them together. Whatever that is the same, put them together. So I'll have ys multiplied by s squared minus 2s minus 3. And if I were to bring this over to the other side, of course the negative is going to be plus of 4. And that is going to equal negative of 1. So I bring this that is not related to ys, I bring it over to the right hand side. And if I were to simplify this, can tell right away, I'll end up with ys multiplied by s squared minus 2s plus 1 is going to equal negative of 1. So ys is going to equal negative 1 over s squared minus 2s plus 1. Alright, so that is going to be one of my variable, which is going to be y. And the thing is that it doesn't matter which one you find first. You can find x first, you can find y first. So these things actually depend on the equation that you obtain after you Laplace transform. Right, so whatever that you obtain first, so the answer is going to be definitely the same. Alright, so now that I already have found ys, I can obtain my first solution. We know that when we have this equation right here, we can have two solutions. The first one is going to be, like, the solution is always the dependent variable. Remember, I have two dependent variable x and also y. So that is why when I solve for this equation, so I wanted to find what is going to be xt and what is going to be yt. And of course, like, now that we already have ys, we can find what is going to be yt. And all you have to do is Laplace inverse. Step number 4. So find yt, the Laplace inverse. Alright, so yt is going to equal the Laplace inverse of negative 1 over s squared minus 2s plus 1. Okay, so I have given, for my students, I have given you the extra notes on this, on revision of Laplace inverse. So I've given you the idea, like for multiple scenarios, so what method are you going to use? So whether you have to use inversion of a shift, partial fraction, or convolution theorem, at this stage you have to know right away. When you look at the function, you have to be able right away to tell right away what method for you to use. And for this case right here, for the denominator, I have a quadratic expression. And if you were to check for this, you will be able to figure out this is actually irreducible. And for a case like this, there will be two choices. Either you can use partial fraction or you can use the inversion of first shift theorem. Right, so now what I'm going to do is I'm going to try to reduce this first. So this can actually be written as Laplace inverse of negative 1 over. Underneath, I'll end up with s minus 1 to the power of 2. And I have mentioned this, the fact that, I mean, this is in the revision video, when you have a constant at the top and a repeated factor at the bottom, so there's no way that partial fraction will work for this case. This is going to be a very special case for which partial fraction doesn't work. And the only way to find the Laplace inverse is going to be inversion of first shift theorem. So that is what I'm going to use. So now let me do calculation over here. I need to find what is going to be this. So according to the theorem, so I put the theorem in green. If I have a Laplace inverse of f of s plus a, that is going to equal exponential of negative at multiplied by f of t. And now my a value, so the only difference is now that I have a minus, and automatically this is going to be a plus. So that will be the only difference. My a value is going to be 1. So my f of s minus 1 is going to equal negative 1 over s minus 1 square. Remember, I did mention to you that this two has to match. So I got questions about this, like the students do the calculation incorrectly, like what's wrong? This two has to match. That is what's wrong. Okay, so now I'm going to have to convert this to f of s, and all I have to do is put plus 1, right? So my equation is going to be negative 1 over, put a bracket around, and then I'm going to have s plus 1 minus 1 square, which is going to be simplified to 1 over s square. So my function f of t, when I Laplace inverse this particular function, is going to equal t. When I put it together according to the theorem, and I'm referring to this one right here, I know that I will end up with exponential of positive 1t. So that is going to be exponential of t. So multiply it, but sorry, I missed out the negative. Do not miss it out. This is a negative and this is going to be negative as well. So therefore, I'm going to have negative t exponential of t for my function y of t. So that is going to be the first solution. So yt is going to equal negative t exponential of t. Okay, step number 5. So now that I already have found yt, I still have another mission. I still have to find what is going to be xt. So if I want to find xt, does that mean that I have to go through like all this process again? I have to find xs and then Laplace inverse and find xt? The answer is no. So what you have to do is, so you have to use back the original equation. Remember what we did before in this equation, the simple one? So when I wanted to find the other variable, all I have to do is use the original equation. So that would be the same idea as well. So you can either use equation number 1, or you can also use equation number 2. But you have to pick very carefully, so which one is going to be the most suited for this particular problem in order for you to find x. And how do you figure that out? So it's going to be like this. So now, this is x that we wanted to figure out. Do we know y? Yes, we already know y. But do we know what is going to be x prime? No, we have no idea what is going to be x. So how are we supposed to find x prime? So therefore, this one is a no. You cannot use this to find x. Okay, remember, we want to find x. Okay, then when I have a look at the second equation, so I already have y. So y is not a problem. And this is what we wanted to find, which is going to be x. And then I have dy over dt. Can I find dy over dt? The answer is yes. I already have y. And I can differentiate then and find what is going to be dy over dt. So that is what I'm going to do. Okay, so now I'm going to use equation number 2. So from equation number 2, let me rearrange the equation. I have that y prime is going to equal negative x minus y, or x is basically negative y minus y prime. And I already have y according to what we have seen before. So yt is going to equal negative t exponential of t. And then I need to find what is going to be y prime. So y prime is going to be the differentiation of negative t exponential of t. And when you want it to differentiate, please bear in mind that every single time, calculate how many t's are there. So my variable is going to be t. I have more than one t in here involved for the case of product or fraction. Automatically, you cannot do it directly. So for the case of differentiation, there are only two things. So either it's going to be product rule, or it's going to be quotient rule. So please do not use integration by parts, the tabular method. Tabular method is integration by parts. So it's called integration for a reason, and it doesn't make sense that you use integration by parts to differentiate. Like, come on, like, that's beyond. Okay, so therefore, what you have to do is you have to use product rule for this case. So this is going to be my u, and this is going to be v, and that is why when I differentiate this, I'll end up with negative exponential of t minus t exponential of t. That will be the outcome. It would be very surprising if you don't know product rule. Alright, so now that I already have that as my y prime, so I'm going to substitute back into the equation. So x, according to the equation, is going to equal negative y, that is negative of negative t exponential of t minus y prime, so which is given by negative exponential of t minus t exponential of t. And let's expand this. I'll end up with a positive t exponential t plus exponential of t plus t exponential of t. If you notice, we have twice of the same function, so that is going to be 2 of that. So I'll get 2t exponential of t plus exponential of t. So this is going to be my second solution. So my x of t is going to be given by this function. So now I have both of them. I already know what is yt. I already know what is going to be xt. That's the end of the calculation. And a simultaneous equation is a very popular exam question. So let me see that almost every semester it comes out, especially recently. It's a very lengthy calculation, of course, because like you have to find two values. There will be Laplace, there will be Laplace inverse, but now you are dealing with two equations. but the mark will be with it. So if the calculation is long, so it's going to be, the marks is going to be a lot as well. But the thing is that when you do simultaneous differential equation, you have to be very, very, very careful, because there is a lot of equations involved, and especially when it comes to the substitution and elimination, because when you substitute or eliminate wrongly, automatically like the whole equation over here is going to be wrong, and there's a high chance that you would come across something that you won't be able to Laplace inverse, that you haven't seen before, right? So therefore, be careful with the substitution and elimination part. So that will be my first example.